We'll now look at variable reluctance stepper motors. The principle of operation. The variable reluctance or VR stepper motor does not use a magnet for the rotor. Instead, it uses a toothed iron wheel shown in figure B. The advantage of not requiring the rotor to be magnetized is that it can be made in any shape. Being iron, each rotor tooth is attracted to the closest energized field pole in the stator, but not with the same force as in the PM motor. This gives the VR motor less torque than the PM motor. A VR motor usually has 3 or 4 phases. Figure A shows a typical 3-phase stepper motor. The stator has 3 field pole circuits, Phi 1, Phi 2, and Phi 3. Figure B shows that the actual motor has 12 field poles, where each circuit energizes 4 windings. You can see this by closely observing the Phi 1 wire in figure B. Wires for Phi 2 and Phi 3 are not shown for clarity. Notice that the rotor has only 8 teeth, even though there are 12 teeth in the stator. Therefore, the rotor teeth can never line up 1 for 1 with the stator teeth, a fact that plays an important part in the motor's operation. The illustration shows the operation of the VR stepper motor. When circuit Phi 1 is energized, the rotor will move to the position shown in figure A. That is, a rotor tooth A is lined up with the Phi 1 field pole. Next, circuit Phi 2 is energized. Rotor tooth B, being the closest, is drawn towards it, which is figure B. If circuit Phi 3 is energized next, the rotor would continue counterclockwise another 15 degrees by pulling tooth C into alignment. Notice that the rotor has to move only 15 degrees for this alignment. The step angle for the VR motor is the difference between the rotor and stator angles. For the motor shown, the angle between the field poles is 30 degrees, and the angle between the rotor poles is 45 degrees. Therefore, the step is 15 degrees, or 45 minus 30. By using this design, the VR stepper motor can achieve very small steps, less than 1 degree. Small step size is often considered to be an advantage because it allows for more precise positioning. The VR stepper motor has a number of functional differences when compared to the PM type. Because the rotor is not magnetized, it is weaker and has less torque than a similar sized PM stepper motor. Also, it has no detent torque when the power is off, which can be an advantage or a disadvantage depending on the application. Finally, because of the small step size and reduced detent torque, the VR stepper motor has more of a tendency to overshoot and skip a step. This is a serious matter if the motor is being operated open loop, where position is maintained by keeping track of the number of steps taken. To solve the problem, some sort of damping may be required. This can be done mechanically by adding friction, or electrically by providing a slight braking torque with adjacent field poles. That is a brief introduction to VR stepper motors. Now let's look at a combination of PM and VR motors, which is a hybrid motor.